All right, so I thought I'd talk a little bit about the homework before getting going further. And so which assignment was due? 5, 6? 6, all right. So, okay, final solutions for 5A and P3.5. So, but let's look at those drafts first. So we're asked to come up with a bug class, and that class has 3 methods, and those methods are right here. So let's do that. So let's make a new project, new class, bug.
Do you capitalize bug or does it matter?
So it does matter, and the rule of thumb is that you always want to capitalize class names. Classes are in uppercase, methods and variables in lowercase, and you could do it otherwise, but you're going to confuse everyone. So let's now at the very first day I said what BlueJ gives you is always useless and you should just erase it, and that was true when the programs that we were writing were the ones that had public static void main inside, and it never gave us that. But now that we're writing our own objects, what BlueJ gives us is not quite as useless, so it makes actually a little bit of sense to keep some of it. So like they're giving us some instance variable that we need to replace with our own, and they're giving us a constructor, which is kind of nice to have, and then they give us a sample method. So we'll take those out in a minute, but I'm not going to indiscriminately erase them. Now, some friendly soul already gave me all of the methods that I'm supposed to implement in the bug class. Here they are. And now as I do that, will it compile? No, I wouldn't ask, right? But so what's missing from the methods? Well, not even just the return, but even more basically, each method needs to be followed by these braces here that delimit the content. So I'll put those in there. All right, so let's try to compile. And now here it says missing return statement in the get position. Why didn't it complain about missing return statement in these? Because it says void, so they don't need to return anything. So I'll just return 0 for right now. And now I'm going to have a crippled bug that no matter how much you ask it to move and turn, it always stays at position 0. Poor thing. But it's a bug, it'll compile. At this point here, I could probably go get rid of this sample method thing here. I'll leave this comment in place, and we'll see a little bit later why. Now, so let's move on to the tester. So that's a bug tester, and again, the capitalization. Just stick with the exact capitalization: uppercase B and then the uppercase T, the camel case. Now this is the kind of class that's probably less useful because this one does need to have a public static void main. So I'm going to, I wish I could copy one, but I'm going to type it. So now we're going to put in the tester. Someone was nice and gave me a bunch of stuff that I could put in the tester. So let's do that. And let's just compile this. And see, it compiled with no syntax error, so I'm on a roll here. So the first thing I want you to appreciate is the difference between the bug and the tester. What the tester does is it constructs a bug and it invokes methods on it. So here you see the construction of the bug. Here we invoke a whole bunch of methods on it. We don't implement those methods in the tester. We just call them. In the bug class, on the other hand, we will implement the methods and we don't call them. So on Desire to Learn, I saw a couple of early attempts where people kind of mixed all of those together. And it's your job to separate those two things. So you need to understand the difference between calling a method and implementing a method. When you call a method, you have some object and you call the method on that object. And you don't necessarily know what's going on inside that method. You just call it and hope for the best. When implementing a method, on the other hand, you are given this method body, and then there's some room inside, and now you have to figure out what code goes in there to make that method do its thing. That's a very important distinction. And so your job is to figure out the implementations go in the class, the invocations go into the tester or the demo, or the code that exercises the class. In Chapter 2, we only had one half of that. In Chapter 2, we had a bunch of these testers that called methods. We never implemented our own methods in Chapter 2 because that was not yet the point of that chapter. Now we're progressing to implementing our own methods, but you can't forget the lesson from Chapter 2 that there's also the code that exercises them. So you kind of have to have a split personality. On the one hand, you're a user of these methods, and on the other hand, you're the provider of these methods. And it's something that's very confusing to a lot of people at this stage, and where I definitely get comments that says, I have no idea where to put things. And that's normal. The rule of thumb is that if you're providing the service, then it goes into the class that you're building, like the bug. If you're testing something, then that goes into the main method of the tester. All right, so now let's do some actual work here. By the way, I've just completed the assignment. Right? This is a perfectly good first draft. So at this point, having separated the tester from the class, I've done something that I can turn in. It's going to compile. It's going to run. It's not really going to do anything useful. But let's say we want to do this a little bit better. First of all, the tester isn't so great because what's going to happen when I run this program? Yeah, nothing will happen. It'll run. It'll exit. It's very diplomatic, but it just doesn't say anything. So we wanted to say something, and so it would be a good idea to figure out what do we expect. So let's get its position. And now it says here the position is supposed to be 5, so expected 5. So let's compile it. Let's run it. What happened? Why am I not getting 5?
You think you'd be expected to vote?
Why not? Well, I guess you can't expect too much yet, right? Because I haven't put in any logic yet.
And you're told to return 0.
I said it's always going to return 0, right? So obviously this stuff can't really work. So at this point you can say, well, what does this bug now need to have internally to function? And so that's always a very difficult question when you design your own class. You now have to say, what variables does it need to remember internally? So what's a bug need to remember? Its position, for sure. So let's put that in. Now over here we have an x, so we'll change that to Is it an int or a double? Well, for some reason I said double here in the problem. So I better make it a double. Okay, so then in the constructor I should set the position to 0. Oh, what happens if I don't set it to 0 in the constructor? Does anyone know?
Doesn't have to start off.
As it turns out, it's 0 anyway. All variables inside a class get initialized with 0. But it's considered a good habit to put it there anyway. But just if you forget and it turns out to work anyway, that's the explanation. All right, so now get position should return the position, of course. And now let's try it. Well, that didn't do him any good. Why doesn't it work? Because I still haven't really done anything with it. There's nothing that modifies the position. So at one point I said, did I say the bug is just like a bank account? Or no, that was the balloon.
You said the bug was like the car lab.
Oh, it's like the car. Okay, and then people said, well, we haven't done the car yet, so that didn't do you any good. So we're actually then going to have to think about it. So when the bug moves, what does it do to the position?
You should change.
How?
Adding and subtracting.
Okay, so let's just add first. Okay. Alright, now it's at 15. So it is moving. So now if we look at the tester again, to see that it actually is doing something that's pretty good, I'm going to add another set of print statements here.
It's not turning.
Yeah, it's just not turning. That's its problem. So over here I was expecting it to be at 10. And so my first expectation is in fact fulfilled. If you see over here, it did get to be at 10. And then the turning is not working. It keeps on going to the right. It's not going to the left. Okay, but that one I'm going to leave to you on how to figure out how to make the thing turn. There is a hint in the assignment, and you could also ask questions on desire to learn. You will undoubtedly have noticed that when people did put in questions on desire to learn, that I gave some extra information. So it is worth your trouble to ask a question, because I will take pity on people who do and put in more information than maybe I should. And so sometimes I think I've kind of given away more than perhaps I should. All right, so that was the bug. The next one is the letter. Let me get the letter up here real quick. Chapter 3. Oh, well, that's coming out real great. So the big complaint on Desire to Learn was about the letter, that people said, this has got to be the most pointless assignment I've ever seen in my life. Why didn't I just use system.out.println? And, I have to agree that there is a lot to that. I'll hopefully stabilize here. That, yes, you could just print the letter by doing system.out.println. But you could do all programming by first figuring out on a sheet of paper what the result should be and just use system.out.println. So that's not the point. The point of these simple exercises is to use what little stuff that you know how to do yet and turn it into something that's assignable and checkable. So and you might say letter class is kind of silly, but it's not quite as silly as you think. Every day you're using your email program, and I bet you that in your email program there is a message class. There is a class that symbolizes a email message. And an email message has a little bit more than a simple letter. It has the sender, the recipient, a date stamp, the message, and the message might contain attachments and all that. But it's not that far off from this basic letter class. And when you type away at your email message and you finish a line, it's entirely possible that your email program calls a add line method to add that line to the method. So it's not as entirely ridiculous as it might appear. So we should come up with a tester for this. And let's see, it says in our partial solution, the constructor should be implemented fully, and the getText method should return some string. All right. So let's follow this. Make a new project. Always make a new project for everything so you don't get the dumping ground of classes. Okay, so now we're supposed to have a constructor. What's our constructor supposed to take? It says in the problem. String from and string to. String to. There, I've written my constructor. I know it doesn't do anything yet, but. And what was the other methods that was supposed to implement? GetText. And, oh, sorry, public. This is the return. So it returns a string. GetText. Does GetText take a parameter? No. Okay, and it needs to return some kind of a string. Here's my string. Okay, I'll deal with it later. So let's see, this class should now compile, and it does. Now we need to make a letter tester. Okay, now I need a public static void main. So don't I have a... Oh, I can't find it. In the bug tester I have one. This is not my letter tester. All right, now what did the instructions say? The tester should construct a letter object and print the result of getText. All right, letter, my letter equals new letter from Mary to John. System out, print on my letter, getText. Okay, let's compile it. It compiles. So run it. I am done. Okay, I made a letter, and this is what it printed. Okay, so I'm done with my draft, at least in a very minimal version, right? The draft instructions didn't say that I was supposed to print anything sensible. But of course, it might be a good idea to print something slightly more sensible. So let's say that what we want to print is the Dear John and Sincerely Mary, right? That would be kind of a reasonable start. So let's see how we would do that. In that case, we have to do quite a bit of extra work. We have to remember the sender and the recipient. And the reason why we have to remember them is that we set them in the constructor, and we don't use them for quite some time. We don't use them until we actually call getText. How do we remember them? How does a class remember anything? The brains of the class are its instance variables. Right? That's the only storage that a class has. Every object has the instance variables, and anything that an object needs to remember from one point to another has to be in instance variables. So you should visualize the object as this little creature, with a tiny little brain, and every once in a while you ask it, do something, do something, do something. How are you feeling? How are you feeling now? Do something. How are you feeling now? Do something. And in between those do somethings and how are you feeling now, it might need to remember a few things, like how it's feeling. And it can only do that with the instance variables. So the letter needs to remember who sent me, who am I to, and you need to do that with instance variables. So when you declare an instance variable, there's three parts to it. The keyword private, we want all instance variables to be private so that people can't mess with our object. The type, and the name. And so here it's actually kind of nice that BlueJ gives us a little sample to follow. You see the type, you see the name, and of course you have to change the type and the name to what you want. So now we want to store the sender. How do I do it? Yeah, so the type is a string, and the name is sender, I guess. And then I want to store the recipient, and here's the recipient. All right, now going in the constructor, it says initialize the instance variables. Why the words have never been produced here? And so let's do it. How do I initialize the sender? Yeah.
Can you set sender as from?
Yeah.
Equal to from?
Yes. So that's what I do. And then recipient equals to. Now, in my getText method, now I probably want to do something. So I want to say, dear and from. Okay, I'll do more later. Let's compile it. And it tells me that it doesn't know what's from. Why?
Because from is only applied to the letter.
Yes, so now we have to kind of look carefully at these names that we are floating around. There's from. From is a parameter of the letter method. And it turns out that from is only known from here to here. So in between where it's declared and the closing brace, that's where from is known. And after the constructor exits, from is gone. So from is kind of short-term memory. It's only there for the life of this one method. Down here, it's no longer there. It's a different method, and it's just not there anymore. So I have to use something that's a long-term memory, and that is one of the instance variables. The instance variables are the long-term memory of the object. They always stay around. So what do I need to use?
Private string.
I already have it. I already have the right variable. I just have to use it. It's sender, right. And so that's the one that's declared up here. Don't declare it again. That's a common mistake that people do, that they over-declare these variables. You only declare them once. There's a little slot in memory, and you declare it once, and then you use it. So we just put in sender here.
Instead of from?
Instead of from. Yeah. And now it'll compile. Let's run it. And now it's getting somewhere. Except that was kind of stupid, right? I should have printed the recipient and not the sender. So that's an easy enough fix. And now I might as well put the colon on it. And now we're getting somewhere. Notice the use of concat here. Concat is a kind of a funny function. It takes a string, it adds another string, and then it returns the gluing together of the two. And because that's yet another string, I can glue together the third string. And that way I can build up my expression with a long stream of concats. Someone asked, can I use a plus? And yes, you could use a plus, but I just want you to practice the method call. It's an honest-to-goodness method, so why not practice a human method call? All right, now I want to show you one common error that just about everyone makes at one point in their life. Look at this constructor here. So let's compile this class. There's no syntax error. Let's run it. And now you get a null pointer exception. So this is a runtime error. So let's find out what happened. So it has to do with the change that I made here, where over here I wrote the word string. So I said, don't do this, but I have to explain why does the compiler not reject it as an error. What happens here is we're going to the constructor. Constructor has two parameters called from and to. And now we're telling the constructor to make two local variables called sender and recipient, which is probably not an inspired choice because we also have two instance variables of the same name. But the compiler says, whatever. I'm giving them two local variables, and it turns out local variables win out over instance variables. So these are two variables that are for short-term memory only. They now remember from and to in these variables sender and recipient. And when the method exits, when the constructor exits, all local variables are forgotten. So these things are forgotten. And sender and recipient up here have never been changed. Now, it's such a common error because once you've done a little bit of programming, your fingers are often on autopilot, and you type the string without even thinking. It happens to me, and I've been doing this stuff for many years. Without even thinking, I type string sender equals from, and then it takes me a bit to find that out when I get my first null pointer error. The word null pointer is this thing is it doesn't know with what string to initialize sender and recipient, so it initializes them with nothing at all, or in technical terms, the value null. And then later when you try to use the value null, you get an error. So if you find yourself getting a null pointer error, or the word null appearing on the screen, then the typical reason is forgot to set the instance variables, and this is the most common error. Yeah?
I don't have the screen in front of it, I still didn't compare sender
So you're following along the exact code that I have? I have to have a look at it. Yeah, I'll look at it in the lab. It's I don't think I can debug it that quickly. Yeah, if you follow this along and you have some trouble, then let's show it to me and I'll debug. Or just put on desire to learn and I'll debug it from there. So now, of course, you need to keep on working at this class so that it has everything that it needs, you're going to have to put in another instance variable. So if you look at the sample code in the book, it calls this getText method. I'm not getting it. Yeah? Yeah, yeah. All right, so there's the getText method, and so we're supposed to be calling getText a couple of times. No, sorry, not getText, addLine. What am I saying? So we have addLine. You call addLine a few times, and that adds more to the message text. So somewhere you need to remember all of the lines that have been added, and you need some other instance variable for that. So I think what I did at the time is I made an instance variable that stores the body of the text. And every time that addLine was called, I added another line to the body. And you could achieve that by saying body equals body.concat. That would concatenate a new thing to the existing body, and then you grow the body by reassigning it like that. More questions about these two problems? Yeah?
What do you do for the name of the paragraph?
Oh, if you wanted to add some new lines, then you would add them by doing a concat of \n. The \n is the code for the new line paragraph. Other questions about the bug or the letter? All right, so now I've given you a whole bunch of information about how to code these up, and my strong suggestion would be to do absolutely nothing with any of this information until Monday night. Just relax and do nothing at all, and it will all naturally flow on Monday night, and you'll have your solution written up in no time. All right, so seriously, try to get this coded up as it's still fresh in your memory, and then you have plenty of time to ask questions when things go wrong. All right, well, I guess given the way the time is going, I'm going to continue for 15 minutes with what I wanted to lecture about, and then we'll do both of the labs in the afternoon. So what I wanted to say as new material is actually quite short. And starting with the next assignment, you will have to produce documentation for all of the methods that you write. And that documentation is in a kind of standard format called the JavaDoc format. And so you will be graded on, you'll lose points if you don't put in that documentation. So here's a typical documentation for the bank account, where in the withdraw method, the first sentence says what does this method do. Same thing in first sentence, what does this method do? The second and further clauses describe the parameters and the return value. For every parameter here, you need a param clause, and for every non-void return value, here we have one, you need a return clause. And then you write in plain English later. So that means for the bug, for example, you have 3 methods, so you need 3 comment blocks like that. Oh, minor syntax, the comment blocks start with these symbols and then they end with these. And you can just copy and paste the sample that you get from BlueText. So someone asked, what's the difference between param and return? But it should be pretty obvious. Param is for the inputs, return for the outputs of each function, of each method. Now, what's the point of all of this? When you do that, then that documentation is usable by the public, and it'll look like that. So you can extract it with a special tool, the so-called JavaDoc tool, and it makes these HTML documents where you can see the documentation of deposit, get balance, and withdraw. And they look exactly like the kind of documentation that you've seen before from standard Java. Now every class has this kind of documentation where you see all of these methods like that, and where it says what the method does, what the parameters are, what the return value is. And that text here that you see in great detail, that got in there because the programmer, at the time at Sun Microsystems or now at Oracle, that programmer put in these param and return clauses. So every professional programmer does this for every single method. And students tend to detest that because it's boring. Particularly for really boring methods like get balance. Well, what do you think get balance does? Of course it gets the balance, and I do realize it is intensely boring to write gets the balance and return the balance. But humor me and do it. All programmers do that. It might be nice if there was some better way of doing some of these really boring comments. But the thing is, most professional programmers rely on these automatically produced documentations. Once your project gets large enough, it is essential, it's totally essential that every programmer produces this for their colleagues, because you work together on a bigger project with many people, and one looks at these all the time. And it's very important that these things here have the various comments. Notice there's no code in the documentation. It's only those comments. And so it's really important for other programmers on a team to have some idea of what goes on. So I try very hard to use better phrases than just deposits the amount. So I try to rephrase it a little bit. And so that's always nice. But even if you just say deposits, it's good. Because otherwise what happens, these things here are totally naked. And it looks ugly. And so it's a good habit to get into. And it's one that the grader is going to really insist on. And you're going to lose a point for every comment that you don't make. So I realize it's boring, but it's just one of those habits that one gets into. Sometimes people say, well, why don't we omit the comments from trivial methods, just like those getters, get position, get balance, or something. And I've tried that, and many people have tried that, to come up with rules when you can omit the comments. And the experience that everyone made is people took more time pondering whether or not to omit the comment than it would have taken to write the sucker. So it is actually faster to just write it than to start asking yourself, should I write it, or is this so trivial that I shouldn't write it? So just go ahead, be a pro, and just like everyone else on the planet, write those comments and just get on with your life. After a while, they just roll off your fingers, and you don't think about it anymore. There's 2 kinds of comments that you actually need to write. There's the method comments, then also at the top of every class, you should write some comment that describes the class. So a bug, for example, would be a creature that moves along a line. A simulated creature that walks along the line, a line. Or a simulated bug that walks from east to west and can turn. Or some such thing. Some sentence that describes in plain English. I realize with these very simple classes it does appear sometimes pointless. What's a letter? Say, simulated letter with I know that solves exercise 3.5. So let's put in something. It's a good habit to get into. As these classes become more useful and more meaningful, it becomes easier, of course, to put in real information. And you will find some classes that have several pages of comment to explain how to use them. So, for example, the string class, if we look at the Java doc of string, all of this long stuff that you see here, all of this material here that kind of says how to use strings here, that's all part of the class comment for string. So if you look at the source code of string, actually let me show you the source code of string. So it's in Java lang string. Okay. So interestingly enough, you can look at the source code of all Java classes. And so here's the source code of string. Over here, you see in HTML format that long comment that appears at the top of the documentation. And let's look at a few methods. Here we see some constructors. Let's look at a method that's not a constructor. More constructors, more constructors. Here, is empty. Okay, you look at the is empty method. The is empty method returns whether the string is empty or not. Look at how many lines of code does this method have. Ladies and gentlemen, one line of code. How many comments? 1, 2, 3, 4 lines of comment. The programmer at Sun Microsystems was not too proud to write 4 lines of comment for a method that's 1 line of code. So he found, or she found that that was a useful investment. So it says here, returns true if and only if the length is 0. And what does it return? It returns true if the length is 0. Otherwise it returns false. Obviously this person was also grasping the 4 ways of filling out the stuff. And then there was a thing that says at which version of the string class this was had. And look at this. Every single method. There's not one method in this class that has not been commented. So if they can do it, so can you. So that is the first point that I wanted to make about the reading. And the second point is this pesky stuff about local versus instance variables. So that's been tucked towards the end of the chapter because it is a little obscure. So the variable here, you can see that's a variable declaration because it starts out with a type. If it was just saying change, like over here, we can see that this thing is not a variable declaration. This one here is a declaration because it starts with a type. And this one here, you see, that's just the name. So whenever you see just the name and no type, that means we're using an existing variable. When you see a type, something such as double, or rectangle, or string, that means that we're making a new variable of the given type. So here we're making a new variable called change. Now we have to understand what is the lifetime of a variable. And there are 2 cases. If you have a variable in a method, it dies when the method exits. It is sad, but it is so. Every time that you call the method, and it's very hopeful, the variable gets born, but it lives for a very short time. The method that runs its course, and the local variable dies again. Why do we need them? The only time that you would have a local variable in a method is because there's some kind of a value that you wanted to retain for a short amount of time. And this is actually here a good example on why you would want it. This method here computes change that's been given by computing payment minus purchase. And then afterwards, it resets purchase and payment to 0. It's a cash register. So after it's given the change, then the transaction is over, and it resets these instance variables. And so we have to remember this, because once we've reset these to 0, payment minus purchase is, of course, also 0, the difference of two zeros. So it would be forgotten. So we have to remember it because we want to return it later after we've done this computation. So that's why we use a local variable. We don't need to remember it beyond that, because once we've given the answer to the caller, then that's the end of that, and we forget this local variable. So local variable is there for short-term memory, and sometimes that's what you want. On the other hand, instance variables, they live for as long as the object lives. So this object was a cash register. And it had what instance variables? Yes, how do you know? Yeah, because they're used here and they're not defined in the method, so there must be instance variables. So these are instance variables. And they live essentially forever. As long as the object lives, the instance variables live. When does an object die?
Whenever Java decides not they don't need to use anymore.
Yeah, when no one remembers it. So eventually, if an object is not remembered by anyone, then eventually it's taken out of its misery by the garbage collector. So, but we don't really care about that. So for all intents and purposes, an instance variable, it just lives there on and on and on. And that's the long-term storage. So obviously, a cash register needs to store the current purchase in the cash register, and then when the next item gets added on, it needs to increment that amount. And so it needs to be long-term storage. Why does the payment have to be long-term storage? Isn't that a one-shot thing? Okay. Very good. Because the way this particular class is implemented, payment is used both in enter payment and in give change. So whenever you have a variable that needs to survive from one method call to the next, it needs to be an instance variable. All right. So those are the two things that I wanted to bring up. So let's break for lunch, and then we'll meet punctually at noon we're going to do a lab. We're going to have for about a half hour, we're going to have a 15-minute review of what that lab meant, and then we'll do the other lab, and then we'll be done.